right, hello everyone. Good afternoon. Welcome to Flutter Meets the Physical World. I'm Emily Fortuna.
And my name is Matt Sullivan.
And we are both developer advocates at Google. So today we are going to talk about this thing called Flutter, and we are going to connect it with Internet of Things type devices, and we are going to have a fun demo.
Yes, and we're going to have a bunch of live coding, and we've got a few slides to go through first. But quick show of hands, how many of you have heard much about Flutter before? Okay, number of people. How many of you have actually installed and built a few things with Flutter? Okay, that's better than last year. Anyone actually deployed an app with Flutter? Ooh. And anyone here, looking at you, Emily, built a cool IoT interesting thing with Flutter? Okay, cool. So first thing we're going to do, we're going to get through a couple of slides just to do some introductions. What is Flutter? Well, Flutter started out with building things like this. This is a mixture of iOS and Android apps, all built running on the same code base. And Flutter is an SDK that helps you build, initially, mobile apps. And a couple of things to take note of here. Flutter out of the box gives you a suite of components, UI components for material design. It gives you a suite of components for Apple styling as well, which we call Cupertino. But you'll notice that these aren't your super traditional out-of-the-box styling. They are tweaked and customized. And one of the things that Flutter gives you is the ability to heavily customize your UIs. The other thing to notice is that they're quite, well, I was going to say busy, wrong word. They're quite fluid in what's happening. And one of the things that Flutter does is because it controls its own rendering system, it lets us optimize, and we aim to try to give fluid 60 frames per second in terms of animations and whatnot.
And so Matt mentioned that Flutter can run, of the many platforms, Flutter runs on iOS and Android. And this is the same app running on an Android device and an iOS device. And we actually didn't do any code customization, but you can see there are small differences, such as how you transition from page to page. The scrolling behavior is a little bit different. Fonts are a little bit different. And this all comes out of the box so that when you write your app, you can focus on the interesting parts of the functionality. You don't have to worry about making it look great. But if you want, you can further customize this as well.
And speaking of out of the box, which I should have done at the beginning, what is in the box, Emily?
It's a mystery.
So there's something in the box that we're going to be playing with later on, but I'm not allowed to show you at the moment, so let's keep going real quick. Because the other thing that we have done more recently is Flutter is not just for building iOS and Android apps. We've extended it to also be able to compile down to CSS, HTML, and JavaScript to be able to create web apps that will run in browsers as well. And we'll talk a little bit about how that happens with the compiler chain later on, but Flutter is built in Dart, and Dart is one of the reasons why we can do and target these multiple different platform points. We're going to show you a taster for Flutter for Web a little later on. It's in technical preview at the moment, but we're working hard to get it into everyone's hands.
So, speaking of the technical details of how it works, Flutter, to write your Flutter app, you use a programming language called Dart. And that's at the top of the stack. You will be calling into all the visual components you see in your app. In Flutter parlance, these are called widgets. And the Flutter framework has a lot of built-in widgets that you can use to make your app look great. And because it's also in Dart, you can look at the source code and customize it and modify it as you see fit and step through things as you're debugging. That all sits on top of the Flutter engine, which is primarily written in C++. This is a rendering engine, so there's the Skia graphics for graphics rendering, there's a text rendering engine, and so on. And that is what is actually drawing all these pixels to screen. And then for iOS and Android, there's a thin runner that starts up the engine that then can get your program running. And all of that runs on hardware, x86, ARM instructions. When you've compiled your app down to release, it compiles down to machine instructions, so it can be super fast, 60 frames per second, as Matt mentioned earlier.
Cool. So how does this relate to things like IoT?
Well, you can also run it on things like the Raspberry Pi. And so we've got the Flutter running on the Raspberry Pi, and we've connected it to an external display here. And it's that same app that we were demoing earlier. We wrote an article about how this was done, and you can check it out at the URL or just scan the QR code.
And we'll have that URL again at the end, so don't go madly trying to take it down at the moment. But the cool thing about what you see here is that this isn't a UI running in X Windows or any sort of window management system. This is actually being generated by Flutter directly using the graphics chipset on board.
So another way to write great-looking controls for your IoT type things that you make. And the way that works is actually the tech stack is all the same, except we have a different runner, because again, Flutter has that rendering engine built in, and we just render your app on the Raspberry Pi.
And so if you have other devices that have reasonable CPU and GPUs, then it's relatively straightforward to be able to create new runners for those as well. So Flutter has the capability to be extended to other platforms.
And speaking of extending it to other platforms, Matt mentioned that you can use Flutter to write web pages as well. And so from you, the Flutter developer perspective, your code is exactly the same. You have the same built-in widgets with the Flutter framework, but under the covers, we've rewritten the Flutter engine to be the Flutter web engine. And what this is it's Dart code that produces HTML, CSS, sometimes Canvas if we can't reproduce Flutter widgets with the same fidelity as with just HTML and CSS. And then that gets compiled down to JavaScript using our Dart.js compiler, which runs on the browser you're choosing and then on hardware.
So why are we here at OSCON talking about all of this? Is because all of this is open source. The Flutter engineering team do all of their work on the master branch in GitHub. And if you want to see what's happening on the framework side, Flutter/Flutter is the place to go. If you want to see what's happening on the engine side, we have Flutter/engine. And it's great for you to look at this. It lets you take this and, as I said, be able to create new runners for other platforms. We also love getting contributions. A lot of the functionality that's coming into Flutter is being built by the open source community and contributing back in. So we're very pleased, and we always encourage people who have an interest, go check it out, and if you come up with a new feature or function, we would love to have a PR to help us continue to evolve Flutter. So are we at the live coding piece? We've been through like slides now for about 10 minutes, so.
No.
Okay, no, not just yet. So what have we built? So we've been playing around with ideas like IoT. What can we come up with? And so we created Haberdashery. And for those of you who are Flutter people, it's not this one. That's our mascot called Dash. But what we actually created was, here we go, this wonderful
monstrosity
contraption. Which Emily is setting up now. So we'll get that plugged in a second, and we're going to give you a quick demo of what we're playing with before we jump into some code. So Emily, tell us what we have here.
Yeah.
When you give it some power.
Yes.
We have fire extinguishers dotted around the room, so if this goes horribly wrong, then we should be covered. That wasn't us. We were not rehearsing in here this morning. So what we have here is a Flutter app that can connect to, I have a Adafruit chip in the back of my head, and it connects via Bluetooth to this Flutter controller. And what you're seeing here is we're just using some software that's mirroring the phone that Emily's using.
Yes, yeah, I have a phone here that is connected, and then I've written a control panel to allow my headwear to do all sorts of effects. So I've got this rainbow one here. I have fun things like there's a fire animation. We have bouncing balls.
We're expecting people to video and make memes, because this is going to be all the memes.
And then this is my personal favorite. This is the meteor rain should start up in a second as soon as the balls stop bouncing. There we go. Yes, so all of this is written in Flutter in your control panel. And you may notice that each button has small, subtle animations to suggest what you will be getting on the effect of this excellent piece of headwear here. And so we're going to be coding up live coding up this control panel.
So why don't we quickly just talk about how these things connect together?
Yes. So as I mentioned, we've got this Flutter app that uses Bluetooth to connect to my Adafruit. It's a Feather M0 with BLE on it. And then that connects. We soldered a bunch of connections to these NeoPixel strips or a bunch of lights to then get this amazing effect. As I mentioned, so we have the Feather M0. And I chose it because it is a relatively small chip, but it also has a Bluetooth module on the chip as well, so I don't have to worry about adding more pieces onto the back of my head to have any more things than necessary. We soldered all up, and you have a whole bunch of wires to get 10 NeoPixel strips.
There were more than 10. There was some soldering incidents.
Yes, there were some failed NeoPixel strips along the way. And then I had this wig cap. I sewed a whole bunch of loops on and secured everything with zip ties, because that's the best way to style your hair. And then we put it all, styled it up to make it from a complete Medusa thing to something a little more visible, like you now see. So, on to the live coding, finally. So I have another phone running our slimmed down version. And right now, there's not much to speak of there.
Not a lot.
So this is the page that allows us to connect via Bluetooth to my wig. And first, I'm actually going to change the, So what we have here, there are two files. The first one is, I don't know if I mentioned this, but everything in Flutter that you see on the screen is a widget. So this whole page here is a widget, and it's called Available Devices. Right now, it's not a very interesting widget because all it does is it has this refresh button, which you can barely see in the corner right there.
Yeah, it's not exactly well positioned.
No. So I am going to center that so we can see it a little better.
Cool.
There we go.
And so what's happening here is one of the reasons why we use Dart, again, is not just because it gives us JavaScript and it gives us ARM code or x86 output. Dart also comes with a VM. And so when we're in development mode, we push with the app a virtual machine. And what happens is, as you start to develop with your code, you'll see that we can take, every time we have this set up, every time you save, it pushes the code and ejects it into the app, and you get sub-second, near instantaneous feedback as to what's happening. And that's what we call hot reload. Again, no VMs or anything when you go to production, but for the development purposes, we use it to give this rapid turnaround time.
Yeah. So as you saw originally, we had a list of the Bluetooth devices before, but there's currently nothing there, so that's kind of boring. So I am going to wrap this in another widget called a list view. And this basically provides built-in scrolling behavior. So there's nothing to scroll yet, but we have this list of available Bluetooth devices. So I'm going to make a new widget for every single Bluetooth device so that we can see them on the screen and then connect to them.
And so you'll notice that when we talk about things as widgets, we're not just talking about physical visible UI elements like buttons and icons. We're also talking about the layout. And because we treat layout the same as the physical UI components, we can interleave these to create very custom ways of doing things. And for any of you who have done mobile development before, just doing things like a scrolling list can be troublesome in that you have to worry about what should you recycle, what to do with on-screen and off-screen pieces. Flutter, because we control the rendering, takes care of that for yourself. So you can put an arbitrary number of items into a list view, and Flutter will do its best to, when things are not showing, recycle them or destroy them, make sure they're there before things scroll into views. So it's very straightforward to just use these to create those types of layouts.
Yes. So as you can see, we've got quite a few Bluetooth devices that are around here, maybe some headphones and such, but we're going to connect to my wig. And so now we're at this screen. It has most of the things. So again, I can turn my lights off and on again. But there's a couple that are not styled up.
They're not.
And
Not entirely stylish.
no. So I want, again, to have each of these buttons be able to suggest what the effect is that you're going to get when you see them on the wig. So this breathe effect, let me tap it and I can show you what it does. But basically, it fades in intensity from bright to dark. And so I would like to set, I'm going to change this because that might be a little distracting. To something else. But yes, so what I'd like to do on the control panel is I'd like to set a color and have it slowly fade to black and then back to the color again. So doing that is pretty simple. Oh, and first, I wanted to mention what this screen is. This is the light control screen, and you can see it's very simple. It's just a grid of a bunch of buttons that I've written. And you can say how many buttons or how many widgets across you want on the screen. In this case, I just have 2 across.
And so just like this view, it's very straightforward to create scrolling grids of items as well.
Exactly. So, okay, so we are on this breathe button here now. We have our build method, which I don't think I actually mentioned properly. As you'll notice, each of these widgets has a build method, and this is what Flutter knows to call to draw what it wants to show on screen. So for our breathe method, our build method is just shows a button, and we have that on pressed. It sends a message to Bluetooth to do the effect that you saw earlier. But it's not styled. But doing that is pretty easy. So I'm going to wrap this in another built-in widget called Animated Container. And Animated Container has all these different properties like color, height, decorations, margins, and basically you can set them, and when that value changes, it takes care of animating from the original value to the other.
So here's an example of Flutter's ability to do implicit animations. Looking at changes for state and then handling the interpolation or the changes in animation between it.
So you'll notice also, though, it got mad at me for a second here because it says duration is null, and that's because Animated Container requires you specify the duration parameter because it needs to know how long to do that animation. So I'm going to set this for, I'll make it 4 seconds.
And notice that, again, the developer experience here, you break something, you're going to get immediate feedback in the UI and also on the terminal panel. But then, as you fix it, the app will recover and you can continue on your way. So there's this direct feedback loop, which is very useful.
Right. So in this case, as I mentioned, we want to change the color. So I am going to pass in that color parameter, which right here is set to default color, which is blue. So when I hit save, we should see the blue color, which is great. But it's not changing. And if you look up at this fading button initial description here, you see that it's a stateful widget. The previous widgets we looked at are stateless widgets. Basically, if you have some bit of information that your widget needs to hold and that bit of information is going to change over the lifetime of the widget, then you want a stateful widget. And in this case, the color is going to be changing from blue to black. And so that's the bit of state that we want to hold. So stateful widgets also have a special method called initState that gets called once when that widget is first created. So what I'm going to do is I'm going to set a timer that starts off in initState, and every so often it will change the color to be a different color, and then the animated container will take care of the animation for me.
So one of the interesting pieces of Dart as well is that, like JavaScript, it's asynchronous. So we can do things like use a timer, which comes out of the Dart SDK. And we don't have to worry about wrapping different threads or processes or whatnot. Because we can do things asynchronously, what will simply happen here is Emily has set up a timer. It's periodic. It fires every 8 seconds. And this will be handled by the Dart runtime behind the scenes.
Right, and so here I'm just swapping the color between dark gray and that default color, which is blue. Now, as I mentioned, this is only run when the widget is first created. And since this widget is already on screen, it's already been created. So this timer is not running it. So to do that, I'm going to do a hot restart, which is going to blow away all the state I have. So I'm going to have to reconnect to my wig. But when this button comes up again, that timer will start. So I'm going to connect to this. And we should see this start to change color in a couple seconds.
And so one of the benefits here is that we may have had to do a hot restart in this case, but imagine a situation where you're developing an app, you've scrolled or you've navigated several levels into the app, you have it in just the state you want, and you want to iterate on the UI. And you can do that because hot reload is stateful. Every time you make a change, state is preserved. If you monkey about with the state and change how it's represented, you're going to want to blow away all your state because the app's in an inconsistent state. My state is in an inconsistent state, so you got to restart to have the new state. That makes sense if you think about it. At least it does in my head. So yeah.
Yeah, we're good, Matt. All right. So we have one more button that we want to style up, and that is the color fill. So I'm going to change to a different effect just because I actually have color fill right now. So this is running lights, but color fill, you can see that basically the lights start at the top and they slowly spill down to fill the whole area. So for my animation, what I'd like to do is I'd like to have color kind of slide into frame on that button and then slowly slide out. So for this, we're going to do another animation, and this one is actually going to be an explicit animation. But let's take a look at the widget itself. In our build method, we have this basic button with our onPress method to say what happens when it gets pressed. And there's a stack widget. Stacks allow you to place widgets on top of each other. And right now, there's only one thing in the widget. It's just that text that says color fill. But I am going to add another thing. First, so I'm going to add a container, a colorful container. So container.
So you've seen things like list views, you've seen columns, you've seen containers, you've seen grid views, you've seen stacks. All of the basic building blocks are there from a layout perspective to be able to lay out the app as you see fit.
Right, so that's fine, but I could make it look even nicer if I do a gradient. I just set a box decoration to be this linear gradient, and instead now I have this fading effect, which I think is pretty. Okay, so now we've got the stack with two widgets in it, but we want another one so we can have a different color slide into frame. So I have another version of this that's a green gradient. It's defined just up above here. It's the same idea. But so now I have the stack with a green gradient, a yellow gradient, and the text. Because the gradient is on top, you can't see the yellow. So what I'm going to do is I'm going to wrap that in a slide transition. Slide transition takes the thing that you want to slide as its child, and then we are going to be moving from one position to another. Now, in this init state, we're using an animation controller. I mentioned this is an explicit animation. And what that means that we're using a controller to actually drive the animation. This is more useful if you have a little more complicated animation. Maybe you have a couple things you want to animate all together, or you want to have it go forward in one instance and backwards in another based on user interaction. In this particular case, it's pretty simple. We're just constructing it, and then we're asking it to repeat indefinitely. So we have our slide transition. We're asking it to animate between an offset, which is off the top of this thing, so it's an XY relative to the size of that green gradient, and then animate all the way down to the bottom. And then we have pass in our controller to drive the animations. So now when I hit save, you should see it slowly slides into frame.
Cool.
So that's great.
So a little bit, we have 10 minutes. We have actually about 8 minutes left. A little bit of audience participation, because everybody loves audience participation, and everybody looks nervous. It's virtual audience participation. So what I want you to do is I want you to go to, on your device of your choice, to that URL, please. oscon-voter.web.app, and QR code will work. And so I would like people to head to that. And what we're going to do is we're going to take a little look at a web app, which I am going to here. And I have it, I'm running in, I think I put this in Safari. And so let me do a refresh, see how long that's been sitting there. So we have this amazing looking app.
Looks a little bit like a table.
Yeah, thanks. Somebody's been mocking my design skills all week. And this is written entirely in Flutter. So what we're going to do is we're going to go over, there's some functionality we put into Emily's app. And what I'm going to do is we're going to start the countdown. And what I want you to do is I want you to click on those colored squares because you're going to vote for the color of her hair. Because it's been white so far, let's see what we can do with that. So if I start the countdown here, that should activate it, and you can start clicking on those.
You can vote as many times as you want.
Oh, well,
Stuff
green,
the ballot
red.
box.
We've never actually tried this with more than 2 people, so those numbers are really rocketing upwards. So you can see as the color changes, it flows through. Let's try to get some different colors in here. There we go. Can we get yellow? We can get yellow. We got blue going at the moment. I can click in all of these. And so we can click in these. Oh, and I clicked in the wrong place. As you can see, we have that feeding back. So that's kind of cool. One, and we have, I have to know, it's like red. There we go. Red wins. Okay.
Woo!
There we go. How did red win? Because it's 37.
Oh.
Anyway. Okay, clearly I have some slight issues with my thing, because I should have tried that with more than 2 people playing it. Let's look at how this hangs together when I debug it later. So what do we have? We have a Flutter app, which is our voting web app. This is hooking up to Firestore, which is a real-time database. And so every time you tapped on those buttons, Firestore went, oh, okay, there's a new vote. It patched it back up to Emily's phone, and Emily's phone decided to show what color. I'm surprised it all hung together and actually worked, which is cool. So how does this look? So let's take a little look here. So what we're going to do is we're going to take this not so awesomely styled table/div looking web app, and we're going to make it look a little nicer just for a few minutes, just to give you a taste for the Flutter for Web pieces. So what I'm going to do here is I have my Visual Studio Code open, and we have a simple enough app. And what I'm going to do is I'm going to focus on the voting button. And to show this, this is a tech preview. So I'm going to run in the master branch of Flutter, and I'm going to do it from the command line, so I don't have to mess around too much. And Flutter has a very fully featured command line. You can do pretty much everything in the command line, as well as having it powered through IntelliJ, Android Studio, and Visual Studio Code. And I'm basically going to say, please run this in Chrome, so I can use the Chrome debugging tools to play around with it. So at the moment, it's going away, it's putting everything together, it's compiling it up, and it is going to launch me a development window. So there we go. Here is my app running in...
Flutter app running in Chrome.
Flutter app running in Chrome. And so that's great. What do we have here? Each one of these large squares is an instance of a voting button. And we're passing in this votes parameter, which basically gives us a color, what the current vote value is, and an ability to vote. So the one thing we don't have working yet in the web piece is hot reload. But I can do a hot restart, which I'll have to activate from the command line, and that's going to refresh the browser. But we're working on bringing in-browser restart and reload as well. So I can go here, and I can look at flat button, and I can go, oh, here's a bunch of things I can do. Let's not make it square anymore. Let's go in, and we'll give it a shape. And this time, I'm going to give it a circle border. So we have this circle border. There was a lively debate. How many sides does a circle have?
Infinite number of sides. Calculus, come on.
Okay. According to Flutter, we just have to set the border side once. So it's got one side. So we're going to give it a border of 10, and this is going to give it a semi-transparent border. So I'm going to go down here, and I'm going to do a hot restart. And OK, great. So again, this is all compiling down to web-appropriate code, web-appropriate code.
JavaScript,
CSS, and HTML, web-appropriate code. These are a little padded close together, so I'm going to add a little bit of padding. I can do that. And while I'm at it, I don't particularly like the colors of my numbers, so I'm going to make these white, which is cool. Not showing up because I haven't activated hard restart, so I can do that again. Okay, and again, now we have some white, and we have these spaced a little more. I would like to have drop shadow, because that's kind of a, uniquely Flutter thing. Flat button doesn't have the concept of elevation, which sucks. But what does is material. So I can change my flat button to a material, and fortunately for me, a lot of these parameters are the same. It doesn't take on pressed. What I can do is I can give it an elevation of, say, 4. And because it's material, this is not going to auto-center my text, because material doesn't do that, but I can fix that easily by putting in center, and then I can go down here and I can go boop. And now what we have is we have some nice subtle elevation. Final thing is I have completely broken it because material is not gesture enabled.
Yeah, you commented out your on-press.
I comment because it doesn't work. How can I add gestures to widgets that don't actually support interactivity?
You can wrap it in a gesture detector.
I can. So I can go in here, and just to add gesture functionality to a widget that hasn't been designed with it, I can wrap it in something like a gesture detector, which gives me a boatload of things: on tap up, on tap down, secondary, double tap, long tap, short tap, every kind of tap. The tap I want is just simply, look, please record my vote when I tap it. And what I can do with that then is I can simply take my code that I was using down here, pop this in, save this, and then this should, when I do a hot restart, because I always forget to do that, give me hopefully a more nicely styled app, which is, I was wondering about that because it's not showing the zeros. This will give me a nicely styled app where my gestures, which aren't quite showing up at the moment, should work. So with my various bugs in play, let's look at voting once more. So what we're going to do is I'm going to get you to check out your app again, please, your web browser. And I'm going to bring this up again. Now this is inactive, so what we can do here is we can go back and we have a reset. Is that the right one?
Uh-oh.
Oh,
Do we have
okay.
internet problems?
We have some slight issues with this. So let me just, we could try stopping and restarting this.
Okay.
You want to give that a quick fire up?
No, not that.
No, that's the wrong one. That's our last demo from the previous one. So let's start this up again and see if we can get our voting going once more. But this time, let's see if we can make it a little prettier than what it was before.
I wonder if... Huh.
Okay, and I'm going to say that we have network issues at this point. So you got through voting once. You're not going to get through voting a second time, and we would have magically showed you the UI updating in your phone, but it's not going to do that, and the demo gods are not quite with us, and we have 30 seconds to fix it, so that's going to happen. So if anybody would like to see that working, they can come up and chat to us afterwards when we restart everything. But in the meantime, all of the source code for this is available on GitHub.
On my other phone, it works. You can vote.
Really? On the other phone, it works?
I think I just reset.
Really? So you can start?
Try refreshing. No?
No.
No.
I think you got everyone's hopes up.
Okay, never mind.
No.
All right, sorry. I blame the internet.
Yeah. We're going to blame the internet for this because that's the easy target for this. It was the internet's fault. But for those of you who have working internet, you can go to github.com and you can pull down the source code for the mobile, the web app, and the Arduino stuff.
Yeah, all the Arduino
well.
code. So you too can write your own fabulous headwear or just a mobile app or a web app in Flutter.
Mm-hmm. And here's a whole bunch of useful links. To learn more about Flutter, flutter.dev is the place to go. We have a load of tutorials. All of our tech docs are there. There's our GitHub repos. And again, there is the link for the post on the Raspberry Pi. So with that, we would like to thank a couple of people.
Yeah. Whoop. Special thank you to Matthew Wilson for soldering assistance on this wig, and Thea Flowers for being a wig model / stylist.
And with 30 seconds over time, we would like to thank you very much.